Okay, so today we're solving radical equations with quadratics. Pencils down. Let me do one for you. Okay, so just like yesterday, we have the same steps. We just have to add a couple in here. Jesse, turn around, please. Isolate the radical. Is the radical all by itself over here on one side? Yes, so I don't need an isolated radical. Square both sides. So I'm going to square this side and this side. What happens when I square a square root? They cancel each other out. So I'm left with 2x plus 3 equals x squared. Now what? You remember we don't move this one. Why did it do that to me? I know. So this guy stays here. We don't want to move him. And we're going to subtract 2x, subtract 2x, subtract 3, subtract 3. And I'm left with 0 equals x squared minus 2x minus 3. Let's factor it. X and x, what two numbers make 3? 3 and 1, which one's going to be negative? Negative 3, positive 1. So this first one, we'll just take it all the way through formally. X minus 3 equals 0. X plus 1 equals 0. So x equals positive 3, or x equals negative 1. What's my final step? I need to check it. Let's do the checks in green. Sound good? So I need to check it. If you didn't check yesterday, you have to check tonight, or else you're going to get them wrong. Okay, yesterday we talked about how many solutions one of these radical equations has. How many solutions does a radical equation have? One or? No. 1 or 0, right? Why? You guys remember? It's half the parabola. So it either has one solution or no solution. Well, how many solutions do I have here? 2. So one of them obviously doesn't work. So you have to check these, or else you're going to get it wrong on the final. Okay? You've got to check these. You've got to remember when you take that final that, hey, I've got to check these because Mrs. Mahler said there can only be one solution or no solutions with these guys. All right, so let's check 3. If I substitute 3 in here, I get 2 times 3 is 6 plus 3 equals 3. Does that work? That's 9. What's the square root of 9? 3 equals, that's all the work I'm expecting you to do. You don't have to do these big old long checks. All right, let's check the other one. Negative 1. You plug it in. You substitute it back in. What's 2 times negative 1? Negative 2 plus 3 equals x. What's x again? Square root of 1. Does the square root of 1 equal negative 1? Nope.
It's very hard.
What's hard about it? So well, you have to tell me what's hard about it so I can make it less hard. Okay, you substitute back into the equation 2 times 3 plus 3 equals 3. See, everywhere I see an x, I put a 3, and then I check to see if it works. 6 plus 3 is 9. The square root of 9 is 3. It works. Make sense? So that is this. It's pretty easy, right? You see how this one doesn't work? The square root of 1 is not negative 1. Coincidentally, that would make this one if I were to write this down, it would be the square root of 2x plus 3 equals negative 1. Did we learn about these yesterday? It's really not that long. I'm sorry? Why do you have to check them? Why? Because no, you can't have two solutions in these. It's impossible. So one of them is wrong, and you have to check it to figure it out. Yes? Then it's no solution. That would be a graph like this. Yeah, of course there will be. That would be a graph like this, where it starts out here. Does that ever touch the x-axis? That's a no solution one. Okay? All right, make sure you guys have all that written down, please. Fun. All right, let's go to the next example. Yeah, why don't you guys try this one? What's your first step? You don't have to. You can just do it on the desk. 2, 1. All right, so my first step is to square both sides. When I square a radical, it cancels. I'm left with y squared equals y plus 6. It says plus right there. Then what do? Subtract both of them from both sides. I'm left with y squared minus y minus 6 equals 0. Factor. I get y and 2 and 3. Which one's negative? The 3. This is y because I need 2y and 3y to make negative y. So I know I need to make the 3 negative because that's negative. Okay, and then I'm going to solve it. So y equals, when I set them equal to 0, what's y going to equal? Negative 2 and 3. We got to check it. Which one do you think is not going to work? Just by looking at them. The negative 2. Right, because it's a negative, so let's check it. No! Let's use the other idea. If I think it's negative 2 that doesn't work, let's check 3. Then if 3 works, we don't have to check the other one.
Well, you only have one solution then.
Yes, you can only either one solution or none. You like that?
I like that.
Okay, so y, let's set y equal to 3. Three plus 6. Does 3 equal root 9?
Yeah.
Yes. There's my solution. Okay? Everybody understand why we only have to check one of them if we pick the right one the first time? All right, fantastic. Pencils down. Let me do this one for you. What am I going to do to both sides? Square it. I don't have to isolate the radical because it's already by itself over here. So I'm going to square this side, and I'm going to square this side. See how these are a little bit harder? And I'm going to get x plus 2 equals x minus 4 times x minus 4. I'm going to use that same strategy, that rainbow strategy. So I get x plus 2 equals, what's my first? First times first is x squared. Last times last is positive 16. Let's do the inner right above it. What is negative 4x and negative 4x? Negative 8x. See how quick that is? Isn't that easier than FOIL? It's the same thing, I just do a lot of it in my head. Okay, now what? What can I not move? can't move the x squared, so I gotta move everything over to the other side. Negative x, negative x, negative 2. Oh, that's not a very pretty 2. Negative 2, negative 2. Mario, why are you asking a question right in the middle? Yeah, thank you. So 0 equals x squared minus 9x plus 14. Factor that. X and x. What two numbers make 14? 7 and 2. How am I going to make 7x and 2x make negative 9x? Negative and negative, right? See how I'm using the same strategy to do factoring and to multiply? It's the same strategy. So what does x equal? 7 and 2. I wonder which one will work. Take a look at it. If you were to plug 7 in here and 2 in here, which one do you think would not work?
2. I don't know, I'm just saying some numbers. 2. I think that's...
Why wouldn't 2 work, Katie?
Because
2 minus 4 is negative 2, and it's going to make it, right? So shouldn't we try the other one first, the 7? So let's try 7. 7 plus 2 equals 7 minus 4. Does root 9 equal 3? Yep, there's our answer. Did you guys see that, too? If I were to plug 2 in there, it would be 2 minus 4. And that would make this a negative 2 over here, and we can't have this side be negative. Remember that? Make sense? Okay. Make sure you write that down. All right, let's do one more, and then we'll start homework. So you guys do this one. Dang. All right, guys. So this is as far as I went. So you should have got to negative 4 and negative 1. Now let's think about this strategically. If I put negative 4 in here, what would I get? Negative 1. If I put a negative 1 in there, what would I get? A 2. Which one makes more sense? Let's try it. So if I substitute a negative 1, negative 1 plus 3 equals negative 1 plus 5. This makes 2 equals what? Square root of 4, that checks. There's your answer. Yes. Sure. Well, we're going to go into homework right now. All right, guys. What did you learn today?
Quadratic.
Quadratic. Radical equation, right? With quadratics. What does it mean to solve a guys? What does it mean to solve a radical equation resulting in a quadratic? What does that mean? It has an x squared as the first thing. What else happens from that? You get 2 answers, and what do you have to do because of that? Figure out which one's the right answer, or whether neither of them work, right? Okay, which equation would you require factoring to solve for x? Which one would require factoring? The one on the right or the one on the left?
One on the right.
Why? Because there's an x on both sides, and one of them is going to get squared. Good job.
Thank you.
Fantastic.
What was it?
Because there's an x on both sides, on the right.